name is Muhammad Waqas. We're going to solve in this video the General Physics 1 past exam, which is related to chapter 5 to 10 of University Physics. So let's start with the question number 1. So a gymnast with 70 kg mass suspend herself on a rope as shown in the figure. So gymnast is hanging with the rope. So what is the tension in the rope? So tension in that case is equal to the weight because its weight is downward, which is mg. The tension is this upward, so which is a normal force in that case. So T equals to mg. T equals to mg, and when we substitute the values, 70 is the mass and 9.81, we get 6.86 is the answer. Now the second question is a car engine with weight hangs as a chain is linked to O at this point O, and the two other chains as shown in the figure T1, T2 and T3, and if T3 is 1800, find the value of the weight W. So the chain is related to this and it's making an angle 60 degree. So the by geometry, this angle and this angle is the same, and we can have two components of the force, which is T3 sine of theta and T3 cosine of theta, and theta is your 60 degree. So we can substitute. So your weight, which is in the downward, so the corresponding component across the weight, which is the normal, so your weight will be T3 sine of theta, and T3 is 1800 sine 60, and when you substitute the value, you will get 1559 Newton, which is the correct option is C, not B. Now the third question is the toboggan loaded with the students with the total weight slides down a friction free slope of an angle 15 degree. So what is the acceleration? So acceleration can be found out by the Newton's second law, which is the sum of all forces equals to mass time acceleration, and the force which is related to the weight, so force is mg, so it's making an angle theta. So it has two component, the mg cos theta and mg sine theta. So we take the perpendicular component, mg sine alpha equals to mass time acceleration. Mass and mass will be cancelled out, so acceleration is g sine alpha, and you have g 9.81 multiplied by sine 15 degree. So your acceleration will be 2.54 meter per second. Next question. You want to move 400 crate across a lever floor. To start a crate moving, you have to pull 230 Newton horizontal force. This is your weight W. This is your force. So what is the coefficient of the static friction, mu s? You need to find out. So when you are you are pushing the force with this, and the friction force, which is the static friction force, is opposite to it. So in the equilibrium condition, when the sum of all forces equals to 0, so all forces will be like your force or the tension T is in this positive direction and your static friction in the negative direction, opposite direction. So Fs, which is mu n, and the normal force is your weight, which is W in that case. So your static friction coefficient, so Fs, is mu times n, or mu s mj. So your mu s in that case is T by n, which is nothing but 230, which is a force you're applying. It's a tension. And then net force is your weight, which is 400. When you substitute the value, you will get 0.8 Newton, which is this. Next is the question. So next question is, a 750 kilogram car rounds a flat unbanked curve of 72 radius. If the car is traveling at 24 meter per second, this is the velocity, this is the radius, what is the net force acting on it? So the car is moving around a rounds banked unbanked curve with a radius. It means it's moving in a circular path. So centripetal force is mv square over r. We have m, we have r, we have v. Substitute the value, you will get 6000 Newton. Question number 6 is, in the figure shown, the coefficient of the kinetic friction between the block is inclined to 0.9. So this is the coefficient of the kinetic friction. So what is the magnitude of the acceleration suspended block as it falls, disregarded with the pulley as a mass of the friction? So this question is a lengthy question. So let's try to solve it quickly so that we don't waste our time. So the forces along y is normal minus mg cosine theta, and normal is mg cosine theta, where m is 2 mg cosine theta, normal force. Okay, and since we will calculate the forces along x, T equals to T, the tension in the string, hello, mg sine theta minus f of x equals to mass of acceleration. And when you substitute the values over here, you will get the acceleration g plus 2g sine theta minus 2g cosine theta. And when you substitute the value, you will get 4.9 meter per second. So this is the question. So next question, what is the following is the correct unit of energy? So energy is related to the work done, or the kinetic energy, or the potential energy. So we can have any formula which is equals to mgh, or 1/2 mv squared. So m is the kilogram, this is the acceleration, which is meter per second squared, and height is meter, so the unit is kilogram meter square per second squared. So the correct answer is this, not this. A car accelerates on a flat road. The work done of the car engine, because it's accelerating, so the work done is positive. Next question is, Steve pushes a car at a distance b by applying a force at an angle theta to the direction of the motion. It means in the direction of the motion. So how much work did Steve do? So work is nothing but F dot T, which is FD cosine theta. So F is 250, D is 9, and cosine is 30. So you substitute the value, you will get this D, 1949 joule. Next is how fast must a 3000 kilogram, this is the mass, move to have a kinetic energy. This is your kinetic energy. So kinetic energy is defined by 1 half mv squared. So energy is given, which is 30 to 50. 1 half m is 3000, and you need to find v. So your v square will be 2 times 3250 over 3000, and then at the end you will take a square root, and the answer is 1.47 meter per second. Next, an object of mass 1.5 kilogram is acted upon by a force F. As shown in the figure, it starts from rest. A total work, this is work, this is mass. So, what is the final speed? We know the work energy principle, which says that the work is nothing but the change in kinetic energy. So, it starts from rest, which means its initial velocity is zero. So, work done is K final minus K initial. So K final is 1 half mv square final minus 1 half mvi square. So initial speed is 0. So this kinetic energy is 0. And the total work is given 300 joules equals to 1 half. Mass is 1.5 kilogram. So V squared. So V squared is nothing but 2 times 300 divided by 1.5, and you will get V, which is 20 meter per second. Next, how much work? So we need to find the work be done on the spring by a spring constant K when it is stretches 20 centimeter from the equilibrium position. So work done by this spring is calculated as this. So 1 half K is 80, and x, which is x, is 0.2 meters. So 220 divided by 100 is in meters, which is 0.20 meters. So x is 0.2 squared. So the total work done is 1.6 joules. Next question. So a 3 kilogram block is dragged over the rough horizontal surface. This is the mass by a constant force acting at an angle 37 degree. The speed of the block increases from Vi to Vf in a displacement of 5 meters. So again, we're going to apply. So what is work done by the friction force? The work energy theorem. So work energy theorem says that work other is equals to the change in kinetic energy. So now you have a force that is doing the work, and the force of friction is also doing the work. So in that case, your total work will be the work done by the force plus the work done by the frictional force is equals to the change in kinetic energy, 1 half mvf squared minus 1 half mv I squared. So your work in that case is given by, this work is nothing but fd cosine theta. So we substitute over here, sorry, so we're going to substitute fwf, which is 1 half mvf squared minus 1 half mvi squared I squared minus fd cosine theta. So you have cosine theta, theta f is there, your d is there, which is this, and everything is there. Just substitute the value, you will get minus 33.89 joules of negative work, because friction always do to the opposite direction. So your answer is approximately negative 34. So if an object is thrown upward at it rises, which of the following happens to be the potential energy? So potential energy is defined as mgh. So if it height rises, potential energy increases. So potential energy increases. This is not the correct option. An example of the conservative force is the gravitational force. The gravitational potential energy, it could be positive and it could be negative. So a 2 kilogram stone, this is the 2 kilogram stone, starts from rest, which means its initial velocity is zero. Initial velocity is zero, and frictionless hill. Find the kinetic energy at the highest point. So the change in energy is equals to zero, which means the energy conservation law. So what is 1 half mv1 plus mgh1 equals to 1 half mv2 squared plus mgh2. So it starts from here, it has a height, it ends over here, and if we suppose that this height is zero, this will be gone. So it starts from red, so its initial velocity is zero. So we left with these two, and the m and m will be cancelled out. So, or if we don't want to cancel out the m, so its kinetic energy 1 half mv square is equals to mgh1. So this is the kinetic energy we get, and we substitute the value mgh1, h is this, so you will get 19.6 joules. Oh, no, 19.6. The calculation is showing me 3.92 joules. Okay, now moving to the next question. This question is like this. So a block of mass m is released at rest. Rest means its initial velocity is zero. At height equals to 3. Surface, the incline makes an angle 30 degree. The kinetic energy of the block when it reaches to the bottom of the inclined plane, this is the kinetic energy when it reaches over here, how much work is done. So you can do this by, if the external force is there, then the energy is not conserved, then the change in energy is equals to the work other, which is E2 minus E1 equals to work other. Okay, so and this work is done by the friction, other work is done by the friction. So you have E2, which is kinetic energy at 2 plus potential energy at 2 minus kinetic energy at 1 plus minus potential energy at 1, which is work other. So this is what we're going to work done by the friction force we are calculating here. So initially it starts from 0 velocity, its kinetic energy is 0, and it ends at 0 height. So we get K2 minus mgh1 is your work other. So we substitute value again, 1 half mv2 squared minus mgh1 equals to work other, and this work other is the work done by the friction. Just substitute the values, you have everything: mass, kinetic energy, this is the kinetic energy, this, and the GHNN, and you will get 41 4.1 joule. 4.1 joule. Yeah. Next question, which is a block of 3 kilogram is attached to a spring with a spring constant K. This is the mass. Okay. The spring is compressed by 0.2 meter from its equilibrium position. So this is your X. So calculate its potential energy stored. So U elastic is nothing but 1 half kx squared. Just substitute the value, you will get 3 joules. Next is an important question. So a 20 kilogram mass is fastened to high light spring. This is the spring constant pass over the pulley as shown in the figure. So the pulley is frictionless and the mass is released from the rest. Rest initial speed is 0. When the spring is unstretched after the mass drop, what is the speed? So we need to find. How do we find? There is no external force, then the total energy remains constant. So your delta E is equals to 0. This is wrong. So E2 equals to E1. So E2 is 1 half mv2 squared plus mgh2 equals to 1 half mv1 squared plus mgh1. And then starts from 0 velocity and it ends at this ground. So these two are 0. Then there is a spring related to it. So we need to add a spring energy, which is 1 half kx squared over here to 1 half kx1 squared. Okay, so it starts from 0. So this energy goes to 0 as well. So now we left with 1 half mv2 squared plus 1 half kx squared equals to mgh1. So mv2 square equals to 2mgh1 minus kx2 whole square. Then your v2 will be square root 2mgh1 kx2 over m. Just substitute the value, you will get your answer, which is 2.2 meter per second. Next question is A 2 kilogram ball is moving at 4 meter per second. What is momentum? So momentum is P is equals to mv. So m is there, v is there, just multiply it. So in inelastic collision, so momentum remains conserved, energy remains conserved, but kinetic energy cannot remain conserved. So momentum is conserved, but the kinetic energy is not conserved. In an elastic collision, energy remains conserved, kinetic energy remains conserved, and momentum remains conserved. This is for elastic. And for inelastic collision, kinetic energy does not remain conserved. Now, consider the two identical ice boat of mass m1, m2. The wind exerts the same constant horizontal force on each ice boat. The boat starts from rest and cross the finish line as indicated, distance s away. Then the boat 2 of mass m2 crosses the finish line with this line. They they have the same kinetic energy as compared to the boat of mass m because they are same constant force. Now, question number 24. Two billiard balls of the same mass collide elastically. So when the particles or the balls collide elastically, they interchange their speeds. Okay, so one is moving in that direction and one is moving in that direction. So when they collide, they interchange their speed. So ball one move in this direction with 4 meter per second, and ball two will move 5 meter per second to the right. So what is the velocity of ball one after the collision? This one. Next, so a boy with the mass 50 kilogram runs at a speed 6 meter per second. He jumps onto a cart with the 200 kilogram mass, initially at rest. So what is the speed of the cart when the boy jumps after it? So if you see this condition, so we're going to apply the law of conservation of momentum, which says that momentum before is equals to momentum after. So before we have boy having a momentum m1 v1, which is moving, and the cart m2 v2. And after the collision, their momentum, because the boy will be on the cart, then their combined mass, and they are moving with this combined velocity. So we want to find the combined velocity, this v. This v is nothing but m1 v1 plus m2 v2 over m1 plus m2. So v will be 1.2 meter per second. Great. Now the next question. So 26, you throw a 0.4 kilogram of ball against a wall like this. It hits the wall moving horizontally with the speed at left. So this is your speed. And it rebounds horizontally to the right with the speed this. What is the magnitude of the impulse? So your impulse is nothing but the change in momentum. So this is moving in this direction. So this velocity v1 is negative 40, or either you can say that this is positive and this is negative, could be anything, because we take this direction to be positive and this direction to be negative. Then the change in momentum is mv2 minus mv1. Okay, then it's m v2 minus v1. So you have both the velocities, just substitute the values. You will get value 24 kilogram meter per second, which is your impulse. Okay. Next, a 2 kilogram object moving with sorry 5 meter per second with stick and to 8 kilogram object initially at rest and stick with. So the kinetic energy, determine the kinetic energy lost. So kinetic energy lost is nothing but K2 K1 minus K2, then so this is 1 half mv1 square minus 1 half mv2 squared. So we have this v1, this is mass m1, this is mass which is the combined stick 8 kilogram, this is m2. We don't have this v2, so we will find this v2, which is m1 v1 plus m2 v2 is equals to m1 plus m2 v. Okay, so they're moving with the constant velocity, so we will get v2 from here. So v2 which is this v2, because this is initially at rest, so this v2 is nothing but m1 v1 over m1 plus m2. So you will get 1 meter per second. When you substitute the values over here, so the kinetic energy lost is equals to 20 joules. So convert 120 revolution per minute to radian per second. So 120. So we have 120 revolution per minute. So now one revolution is 2 pi over revolution, which is radian, and 1 minute is divided by 60. So just 120 well 2 pi by 60, so we will get 4 pi radian per second. So the bicycle wheel is rotating counterclockwise. So using your right hand rule, curl finger will be the direction of the angular speed, and your thumb will indicate the uh, direction of the omega. So this is the rotation. So omega is directed out of the page. So the graph shows the angular velocity and angular acceleration versus time for rotating body. At which of the following time is the rotation slows down? So if you see this, at this point, the velocity is increasing, and at this point, it's not decreasing. So at 3 seconds, start decreasing. So compared to gearbox, question number 31, compared to the gearbox, gear tooth on the rear stock of a bicycle, the gear tooth on the front sprocket has this. So now if you apply the linear relation with the angular relation, which is v is equals to r omega, So we have two things. One has a smaller radius, one has a bigger radius. So if they're moving with the constant speed, so v1 equals to v2, which is equals to omega r1 equals to omega r2. So one go down, one has to increase. If go down, this has to increase, and this product remains constant. So the linear speed will be the same in that case. Next question is very sorry, is interesting. Three small blocks with each car of mass m kilogram. So and clamped at the ends at the center of length 4 meter, negligible mass, commute the moment of inertia. So the axis of rotation over here. So the total moment of inertia is m r1 squared, moment of inertia I, m r2 squared, m r3 squared. So this is the axis of rotation. So r1 is 0 over here. This is r2, which is this whole length is 4 meter. So this is 2. So this from here to here is 2. And then over here to here is 4, which is r3. Sorry, r3 is 4. So this moment of inertia goes to 0. So we have m r2 square, m r3 square, and when we substitute the value, we will get 10. Please do check these answers, so you'll be sure about this answer. Now, the angular position of the object is 2 meter radius. Flywheel is given by this. Find the angular position in degrees. In degrees. So angular position in degrees at 2 seconds. So you substitute 2 seconds over here, you will get 32. This is in radians. So how to convert this radian into degrees? 32 multiplied by 180 by pi. So you will get 1834 degrees. Great. So the next question is 35. For identical cylinders are each acted before the acted on by the forces of equal magnitude, which force exert the biggest torque? So torque is nothing but r cross f, which is rf sine of theta. So when the theta is 90 degree, it will give the maximum or biggest torque. So in that case, theta is 90. In that case, they are the same, the opposite, and there is opposite as well. So in case A, this is the so which of the following is a condition for the conservation of the angular momentum? Conservation of the angular momentum. So the conservation of angular momentum is related to the torque, because the conservation of linear momentum is related to the force. So because rate of change of angular momentum is equals to applied torque. Okay, so the system must have no external torque. Okay, question number 37. So a rigid body rotates about the fixed axis with the angular velocity this. Its moment of inertia is this. How much the magnitude of the net torque? So torque is nothing but I alpha. Okay, so how do we have I, but we don't have alpha. So alpha coming out from here. Just take a first derivative, angular velocity derivative. So 5t, and the t is 5 second, which is 25. So tau will be 2 multiplied by 25, which is 15 Newton meter. What a wheel, question number 38, a wheel, a moment of inertia of 2 kilogram, experience a torque of this. What is the angular acceleration of the wheel? Angular, so tau is the same formula which we used in the previous question. So alpha is tau over I. So 10 over 2, which is 5 radian per second squared. So a 6 kilogram particle moves at the right with this velocity. The angular momentum. So angular momentum is r cross p, which is rp sine of theta. So, or the unit vector in the direction. So rp. So rp sine theta. So r p sine of theta. This is your r. You have v. You have m, and you have theta. So this, and if you apply your right hand rule, so the answer will be 144 into the page. Okay, the last question. A boy of mass m 30 kilogram standing on the rim of a large rotating disk, omega 2 radian mass about an axis through the center, the disk of mass 150 kilogram and radius r. If the boy moves to the center, the boy moves to the center, it was there and it is moving to the center. Calculate the angular speed of boy disk system, whole system. So now we're going to apply the conservation of angular momentum, which is L1 equals to L2. What is the angular momentum? Angular momentum in terms of the angular velocity is I omega. So what was the angular momentum prior to the movement of that boy is I boy plus I disk, and they are moving with the same angular velocity. Then I boy plus I disk. So the boy moves from here to here. Its radius goes 0. When the radius of the boy goes to 0, its moment of inertia goes to 0. So this goes to 0. So this we need to find I boy plus I disk omega 1 divided by this. So you calculate, you have I boy and I disk, and this is the radius. So I boy can be find out the boy mass, which is 30, and the radius is 4 square. So you can find I boy as well. And substitute these values into it, you will get 2.8 radian per second. Hopefully you enjoy this video. At the end of the exam, you will get these kind of formulas. So be prepared. Best of luck. See you. Goodbye.